I'm going to start doing this again because I've done it with the wrong settings. So switch on, and we're going to I'll set this up to sensitivity to 600 like always. Now, detector, I'm detecting from A, which was my mistake last time. I'm going to change, so the rate is counting every 10 seconds. It's going to work out an average of how many counts it's getting per second. I'll turn on the loudspeaker so you can hear the clicks, and I'm going to stop. Now, nothing's going to happen at first until we've got up to the first 10 seconds time period. So it's counting how many counts. So after the first 10 seconds, so this is 10 seconds, on average we had 0.4 per second. Need to write that down. Second time period, we've had no counts per second. Third time period, no counts per second. Fourth time period, we've had 0.1 counts per second. Okay, so we're going to be detecting a certain amount of radiation that is naturally being detected by the Geiger-Muller Tube. You need to note down each of these time periods, the average count rate, so we can work out how much background radiation there was in this kitchen before we do any more experiments. So, best way to do that is leave it for a good long amount of time to get a good average. So maybe 20 time periods, and we'll work out the average over those 20 time periods, because the thing about radioactivity is it's random, it's spontaneous, we never know what's going to happen, so we have to work out an average background rate that there was before we do any experiments with any radioactive isotope that I might have, to know how much there was on average before we even started. So I'll leave you noting down the count rate per second for 20 time periods. So that would be 200 seconds, that would be 3 and a bit minutes, whilst I go and have a little drink of water. Okay, so that's 20 time periods, which is good enough for GCSE. A-level guys, I think you need to do it a bit longer, so speed up the video a wee bit and you take down the results. Let's go up to maybe 40 for you guys. Okay, so that's 40 time periods, so A2 guys, I think you should be happy with that. Now, just very quickly, to prove a point, you never start a microwave without having anything inside. But let's go back to good old electromagnetic spectrum. Now, microwave radiation and gamma ray radiation is all on the electromagnetic spectrum. True. Okay? And a lot of parents and stuff and people seem to think that you get radiation coming from microwaves. Microwave radiation, yeah, but microwave radiation is not ionizing radiation. So we should see no difference in the count rate when I switch on the microwave. Okay? Same with your mobile phones. Yes, they do use microwave radiation, but it is not ionizing radiation. So you don't get radioactive, you don't get genetic damage or anything, because the microwave radiation from the microwave, but the only thing you do get is the energy is absorbed by water molecules. Do we get any difference on our Geiger-Muller tube, the microwave switched on? Nothing. Stays virtually exactly the same. Okay,